All right, folks, it's Back in action here. In this video, we are going to go over squares and trapezoids. So let's start here with our squares. Let's go ahead and list our area formulas. Now, what we want to remember is that a square is really a parallelogram that is also a rhombus and a rectangle. So the area of a square could be found by doing base times height, thinking about its parallelogram or rectangle features, but we can also find the area of a square by doing 1/2 diagonal 1 times diagonal 2, thinking about its rhombus features. Now, of course, since it's a rhombus and a rectangle, the area formula for the square could also be written as 1/2 the diagonal squared, since the two diagonals will be the same. So looking over here at our square, let's just do a quick little reminder. We're going to have 4 right angles here. We're going to have these 4 pieces inside are going to be congruent. We could give ourselves a reminder that the 4 sides are congruent, and you could even go so far as to write in the 45 degrees on all of those angles if you wanted. We can also add in that the diagonals are perpendicular. So just as a reminder, we mentioned this before, that we have a right triangle right there, and then we also will have a right triangle here, and both of those right triangles are 45, 45, 90 triangles. So let's look at a couple examples. We're going to have the area of a square where we're given the diagonal. Now, if we are just straight up given the diagonal, all we have to do is follow our area formula, and we're just going to do our 1/2, and we can do our 7 radical 3. And although we could write it squared, I'm going to go ahead and I'm going to write it twice for us here to remind ourselves that when we square something, we have to multiply by itself. So this would be in our numerator. So 7 times 7 is 49. That's going to be 49 times 3 is going to give me 147, and that's still going to be over 2. So that'll be our centimeters squared. Over here, if we want to find the area of a square and we're given the perimeter of it is 28 radical 3, we first need to remind ourselves that the side of the square is going to be 7 radical 3. Taking that 28 radical 3 and dividing it by 4. Then when we go ahead and we do our area formula, since now we're working with the sides, we can just do our base times height. You've got to be able to fluently move between the two. So 7 radical 3 times our 7 radical 3 is going to give us an area of our square of 147 units squared. Okay, so that's just the main idea here, is recognizing that if you know the diagonals to work with that formula, and if you know a side to work with the base times height. Now we are going to flip to our trapezoids, and we're just going to look at some examples of some things that we can do with our trapezoids. And on our trapezoids, what we want to do is we want to look at our area formula for the trapezoids. So our area formula for our trapezoids is going to be 1/2, and it's going to be our base 1 plus our base 2, and then that is going to be multiplied by the height. Now, what I want to call your attention to is that this portion right here is actually our mid-segment formula, so we can rewrite the trapezoid formula as the mid-segment times the height. And down here, I've got another spot where you can write that mid-segment formula, and we can go ahead and write 1/2 base 1 plus base 2. All right, now let's jump into our example here. So when we take a look at this trapezoid here, it is not an isosceles trapezoid. So if we want to find the area of this trapezoid, we're going to need this base, we're going to need this entire base here, and then we're also going to need the height. Okay, so in order to get us there, what we're going to do is we're going to first look at the fact that this piece right here has to be 22. That's going to allow us to get the rest of that base, but we still need to know this height. I'm going to call this, I can put a little h right here, this height. Now, working our way here, we can see we have a right triangle, so we can do a little Pythagorean theorem here and say our 30 squared is going to be our 18 squared plus our h squared. Working through that Pythagorean theorem, it's actually a nice Pythagorean triple. We're going to get the height of this trapezoid is 24. So this is 24. Well, this 24 is the same as this 24 right here. There's still going to be the distance between these parallel lines. So again, I can do the Pythagorean theorem to get us to this last piece right here, and we're going to call this piece here x. And now I can say x squared is 24 squared plus 7 squared. And again, I have a nice Pythagorean triple, and that piece is going to be 25. So I'm going to put a 25 in here. Now, from there, we can just use our simple little formulas. So the area formula is going to be, our area is going to be 1/2. We're going to add our bases together. The top one is 22. And this bottom, the length of this whole side right here is going to be 47. And the height we already found is 24. Multiplying that all out gets us an area of 828 units squared. The perimeter, of course, we just have to add up all of our little pieces. We don't want to assume that anything is an isosceles, so our perimeter is going to be 124 units. So that'll take care of that. Last thing that we want to do is we want to take a look at this isosceles trapezoid and a little sample that we could do here. So remember, on the isosceles trapezoid, our base angles are going to be congruent. So if this is 42, this other base angle needs to be 42. And then since it's a trapezoid and these are parallel, these angles should be supplementary. So we can also fill in this angle here is 138, and that other pair of base angles is also congruent. So we get two pairs of congruent base angles. Now, I also want to look at just some algebra that we can do here. If I'm given some information about my two bases, and I'm given an expression here for the mid-segment, we can use that, and we can use our mid-segment formula to solve for x. So I'm just going to substitute in. My mid-segment is 2x plus 1, just substituting mid-segment for 2x plus 1. Then on the other side, I'm going to have my 1/2, and I'm going to write each of my bases in here for here and here. So I'm going to have my x plus 3 plus my 5x minus 33, and now I'm just going to do some algebra. Now, just a little tip. I would take this 1/2, and if you multiply both sides by 2, this 1/2 disappears, and then we can just distribute it to the other side. So we'll get a 4x plus 2, and now we can collect some like terms, and we'll have 6x minus 30. And now this is going to be pretty easy to solve. We don't have to worry about fractions. We're going to get a 2x. We're going to get a 32 when I move the 30 to the other side. So our x equals 16 when we're all done. Okay, so those are going to be our properties related to our trapezoids and our squares, and then we'll do more practice when we get back from break.